Okay, so what we're going to talk about today is trig applications. So essentially what trig applications are is they are real-life problems in which we use the things we've been using, learning the past 2 lessons to answer different types of questions. So we've been talking about law of sines, law of cosines, and area of a non-right triangle, right? So all of those things are going to come into play when we kind of work through these different problems. So the key is to be able to read these problems, pull out the important information, and figure out what exactly it is that they're asking for, okay? So we're going to read the first one together. We'll probably only get through 2.5 questions. You guys are going to work in your groups to try and figure these out on your own. I'm not baby stepping you through these, okay? So number 1 says, measuring across another river. A surveyor would like to measure the distance across the river, similar to exercise 1, which we don't have in front of us, and that's okay. The surveyor spots a point D, find D. Everybody see D? Surveyor spots a point D across the river at an angle 18 degrees from point A, as marked on the diagram. Everybody see point A? Okay, so picture yourself standing at point A, looking at point D. Okay? The angle that your vision is looking, right, is 18 degrees. Make sense to you? Okay. The surveyor moves 1,000 feet downstream, so he's walking 1,000 feet, and he stops at point B. Measures the angle to D as 37 degrees. So looking at that same point 1,000 feet downstream, now we're at an angle of 37 degrees. Does that make sense? Okay. Determine the distance across the river from point C to D to the nearest foot. So what are we looking for? CD, which is like the height of that little triangle, or I guess the big one as well, right? All right, so given that we're looking for CD, do we have enough information? No, not yet. So what I want you guys to do is talk with your group. I want you to figure out any information that you can find that's not there, and then figure out your steps in order to solve for CD, okay? Figure out what you need to find in order to get that answer. Once you think you have an idea and a game plan, I want you to call me over, talk to me, and I'll tell you whether or not you can proceed, okay? And all the answers. Okay, so every single one of you told me that your game plan was to find DB, and then with that information, find DC, right? And then every single one of you said, okay, I'm going to find out any extra angles that I need, and I'm going to use law of sines to find y, and I'm going to use law of sines again to find x, right? Okay, so in order to find y, we needed some extra angles. So I went through and I found those extra angles. Are we all good with that? Okay. So to find y, we did y over sine of 18 equals 1,000 feet over sine of 19. We're good? We did some cross multiplication and division, and we found y to be approximately 949.1622. Why didn't I round at this point? It's not the end, right? We're not at our what we actually want. So we want to keep as many decimal points as possible until we get there. So then to find x, we went through with my information for y, and we used law of sines again. So we did x over sine of 37 equals 949.1622 over sine of 37. Are we good? Nope, I did a boo-boo, didn't I? Sine of 90. Sorry about that. And when we cross-multiplied and did our division, we found x to be approximately, what? Yeah, 571 rounded to the nearest foot. Okay, we good? Not bad, right? Okay, so let's go on and look at the next one. A portion of a barn in the shape of an isosceles triangle must be painted. The base of the triangle measures 30 feet long and the legs measure 20 feet each. A can of weatherproofing paint will cover 50 square feet of the area. What is the minimum number of cans needed to cover this triangular portion? Justify your answer. All right, now, I want you to, as a group, talk about what this question is asking for, what you need to find in order to answer the question, and how you set up the diagram and the actual work behind it, okay? Before you proceed, I want you to call me over. I'm going to check your game plan, and then you can go on. Got it? Go. Okay, what do we get? We got 4 cans, right? Okay, so let's talk about how we did it. The problem says that you have an isosceles triangle, which means 2 sides are equal, right? Base is 30, and the legs are 20 each. So if we're talking about painting this triangle, we're talking about the area of the triangle, right? We know that 1 can of paint is going to cover 50 feet squared, or square foot of this triangle. So we need to know what the entire area is of the triangle in order to figure out how much paint we need, right? How do we find the area of a non-right triangle? Yeah, k equals 1/2 AB sine C. Okay? But we need what in order to find this? We need the angle. How do I get it? We use law of cosines to find an angle. Now I chose this angle to find. Okay, you could have chosen any angle. Doesn't matter what angle you use. No. Okay, either way is going to work. So you had to set up law of cosines. And I'll call it A. Okay. And you should have found A to be approximately 83 degrees. Now, what was wrong with that? Yeah, when we solved this all out, we actually wound up getting cosine of A to be -1/8, right? That we don't like because cosine's negative in the second. So when I wound up with A to be approximately 83, I needed to adjust and find the angle in the second quadrant, which was about 97 degrees. Agreed? So once I had that angle, then I could use my area. And remember, it's the angle on the 2 sides on either side. And we found the area to be approximately 198.509. Did we stop there? Why? It's asking for how many cans of paint are going to be used, right? So I know 1 can covers 50 square foot of this triangle. So how would I figure out how many cans I need? Yeah, just divide this by 50. And we get 3.9 approximately, right? So we need 4 cans of paint. Now, Stephen did it very differently, which is fine. It's just another way to work it, okay? He said, I know it's isosceles. I could draw the altitude and make a right triangle. I know that it bisects it, so this would be 15, right? Find the missing side by using Pythagorean theorem. And then the area of a right triangle is 1/2 base times height. You would double it because you have 2. So now you've got your area, okay? And then divide by 50. So that would work as well. Now, that works if it's an isosceles triangle or an equilateral, okay? But that's the only time it's going to work. So you need to make sure you know how to do it both ways, okay? Good? Awesome. Let's look at the next one, guys. Okay, so a crane is being created by 4 steel members, bold. Okay, those are your steel members, the bold lines, the bold segments, as shown in the diagram below. It is known that AC is 10 feet, AB is 8 feet. Measure of angle A is 40 degrees. Measure of angle CBD is 65 degrees, and the measure of angle D is 45. A, determine the length of the support member BC to the nearest 100th of a foot. So here's BC. This is what I want, right? And I want it to the nearest 100th of a foot. So talk to your group, figure out your game plan, call me over, and we'll talk. Okay, so every single group here told me to use law of cosines. You were absolutely correct. Why did we use law of cosines? What did we have available to us? 2 sides in what angle? There's a word for that, right? Somebody help her out. We had 2 sides in what angle? The included angle, right? We had 2 sides, and we had its included angle. We were looking for the opposite side from that included angle. That's law of cosines, okay? So what you set up should have been this. And very simply, all you needed to do was take the square root of both sides, and we got to the nearest hundredth, because that's what it's asking you to round to, 6.44. Make sure you include your units for feet. Okay? All right, so you're going to go ahead on to B. You don't need to check with me for this one. Let's see if you can work it out on your own. Okay, what did you use? Law of sines, what'd you get? 8.25. Good. So B over sine of 65, and I called this A, but that's okay, equals 6.44 over sine of 45. When we cross multiply and solve, we get B to be approximately 8.25 feet. Awesome job. Your homework in your packet tonight, this is pages 10 and 11 in your packet. So your homework is just to do number 4. You got 1 to do. It had better be done for Monday. Understood? Yes. Okay, so please make sure you get that done, and I will see you all Monday. Have a good day.